For the second half of our introductory lesson in Chapter 8, we're going to look at statistical analysis of data and some vocabulary that goes along with that. The three measures of center, measures of central tendency, are mean, median, and mode. Just reviewing, mean is the sum of your data divided by the number of items. Sum of the numbers divided by the number of numbers is another way I've heard it said also. Mean is often referred to outside of the educational world as just average. So if you hear that word used, adding all the data, dividing by how many numbers there are. We use mean most of the time when we are analyzing data. The one exception would be if you have outliers. If your data has outliers, then we're going to look elsewhere. Outliers are numbers that don't fit in with the rest, too big, too small. So numbers that don't fit in. Next up would be median. It's the middle number or the mean of the two middle numbers. We use that when this data has outliers but no big gaps in the middle of the data. So to find median, you order the data and then find the middle. If there are two numbers left, so if you have an even number of items, you'll get two numbers left in the middle, and then that's when you find the mean of those two middle numbers. So you would add them together and divide by 2. And then finally, mode is the number or numbers that appear most often, and we use that when the data has many repeated values. Things to know about mode: there can be no mode. If all the data appears the same number of times, there's no mode. There can be one mode if one value sticks out, is repeated more than the rest, or there can be more than one mode. If you have several numbers that appear the same number of times, then those values could all be the mode. Then the next thing is margin of sampling error. This is a simplified formula for that. Looking at margin of sampling error, that gives us a acceptable range, acknowledging that there is going to be error in our data gathering practices. And that formula is here. 1 plus or minus 1 over the square root of n. So by default then, the larger your sample size, the smaller your margin of error will be. And that kind of makes sense in the real world. The more people you ask the question to, the more likely you are to get an appropriate response. There are a lot of people surveyed. You have a lot of data to work with. If you only survey 4 people, your data is going to be fairly inaccurate. So looking at this example here, the table below shows daytime high temperatures for a week. So looking at the data, it's fairly close together, right? Our low value is 64, our high value is 79. None of the data seems to be outlandishly high or low, so there will be no outliers in this data. So to find the mean, we will add the data and then divide by how many numbers there are, right? So there are 7 values there. So we type all of our data into our graphing calculator. To sum it up, we get 481. And then divide it by how many numbers there are, which would be 7. So we have an average or mean temperature of 68.7 degrees. For median, we would need to order our data, right? So there's 64, 65, 67, 68, another 68, and then 70, 79. Right, so that there's 7 pieces of data. I know that the 4th piece, right, if I wanted to mark from each side, 68 is my median, and 68 is also my mode. It is repeated twice when the others are only in there one time. So then the question is, what is the best measure of central tendency here? Well, by default, we would go with mean, because that is the one that is typically considered the best measure, and we chose that one because this has data has no outliers. So mean because there are no outliers. If we had some piece of data that was considerably higher or lower than the rest, then we might look at median to be our best measure of center. And here, 3,600 random people found that 71% of the 3,600 people said that they liked the newest Ryan Reynolds movie. To calculate that margin of sampling error, we use that formula again, that plus or minus 1 over the square root of 3,600. Okay, the 3,600 is my sample size. So the plus or minus 1 over 60. In reality, I would probably just type that original expression in, right? 1 over the square root of 3,600. So we get plus or minus 0.016 repeating. And because this is a percentage, we would want to change this to a percentage. So we get a plus or minus 1.67%. Right, and then this interval would be the range that contains the valid responses. So we would take that 71% that said, yes, we like that new movie, and then we would go the plus or minus 1.67 from that in both directions. That's what that interval is going to be. So I would take the 71 minus 1.67%, 69.33, 2, and then 71 plus the 1.67, 72.67. Right? So our sample size is fairly large, so our margin of error is fairly small. Looking at some of the other examples, this one, we have ACT data. So ACT would be the less famous competitor of SAT. So looking at their data, they have the average scores by state. And it would take you a minute to add those up. So I'm just going to tell you ahead of time that the sum of the data here is, sum of the data would be 1059. So for that, you would take the 1059 divided by the 50 states. 1059 divided by 50. We get 21. Just go 21.2, since all of our other data is rounded to the nearest 10th. Then to find the median here, you would have to order all 50 of these data points. And I'm just going to tell you that it's 21.4, and then that the mode of 21.5, that actually appears 5 times. And again, best measure of central tendency would be this mean, because just glancing at the data, there are no outliers. So on the next slide, it asks, what if somebody accidentally typed in 203 instead of the 20.3, right? They omitted the decimal point. So I'm going to pop back to this slide, and we're just going to talk about E, F, and G real quick. E and F and G. And so what happens to our mean if this value accidentally is entered as 203? Well, you're going to have, all your other data is in the 19s, low 20s. So your 1059, if we subtracted out the 20.3, right, and then added 203, that would give us our new sum. They're not asking for an exact, but if we increase our total points by about 180 points, this value is significantly larger. The 203 is 10 times larger than the value it is intended for. That is going to increase our average, and it does by about 3 points. Right, so if I divide that by 50, right, our mean goes up actually more than 3 points, 3.5 points. That's about an 8% increase. So that definitely makes our mean invalid. Because of the number of data points being even and where they fall in, there's actually, in this case, no change in our median, and there is also no change in our mode. So being that all three of these right now are fairly close together, that tells us we have a pretty good analysis of that data. When you start seeing one of them being way different than the other, it's worth taking a look at. So that answers those questions there. So looking at the rest of these examples, 4, 5, and 6 all have this same survey of, but the number of people surveyed is going to decrease. So for this first one, we would get plus or minus 1 over square root of 4,261. That's going to give you plus or minus 1.5%. Okay, and so you can work through the rest of these, and you're going to see as your in example 5, your survey size is going to go down to 360, and then in example 6, it's going to go all the way down to 38. And I want you to look at what happens to your sampling error and your intervals as these decrease, your sample size decreases, right? So for this one, you're going to get your interval with 4,261 people. Your interval is going to be 76.5% to 79.5%. You're going to get a pretty big interval here for this last one. So I want you to work through that, and then you should be ready to work on your assignment.